Hello guys, this is Krishna from Team 9. Welcome to our project presentation on cyber threat detection using machine learning model. For that we're using the Jupyter notebook to train and visualize the data and etc. those things. And for now we have to give a path to Jupyter notebook our project file so that we can access that from the Jupyter notebook. So wait just for a few minutes. Let me check where is my file located. It's not showing. Let me paste it in another folder. Okay. Our project focus on detecting malicious URLs using ML techniques, which are decision tree, SVM, XGBoost, like that. And for that, we entered into a IPYNB file, which we have codes in it to process and visualize the data. In our case, we are using URL-based dataset. And let's see what these libraries in our session later. For now, let's see in this project, we work on Jupyter Notebook for training the data and save the data and model, and working on URL data to identify potential threats. First step involves data preprocessing, where we clean and organize the dataset. So that's what we do in that. And here we have when we are executing the files, the executed files are stored in this folder like app, cyber attack URL, like that. And this is this pandas we use it for import the data and read the data, and its head is used for to display the first 5 rows of the data, and tail is used for last few records of the data. So here, as I told you before, these all are that IPY.MP checkpoints. We have files and static templates. These are all app. We have codes and everything in it, which we use it for this project. I explained it one by one later on in our section. For now, let's see. Whenever we execute these codes, we get a data that's stored in these folders. And a model one dot pickle is nothing but we store our model in that. And I also told you why we use pickle and what is it used for. I'll explain in our session. So just know what is pickle. It is a file used in Python to serialize and save objects, including machine learning models. So that's what it is used for. And it is used to store trained models, and pickle is used for fast loading and efficient for deploying in real world applications. So that's why we're using pickle to save the model which we are training in our datasets for prediction. And then this IPYNB file is trained with a model.pickle file. So we use these two files to to read the thing. And after that we train and test the data. So before that, you see we have IPYNB checkpoints and app, statics, templates, and cyber attack URL, model one.pk, everything. These all are our file ports where we store it. And this cyber attack URL.xl is our data set, which are URLs based data set. So next we know how to train the data. First, collect dataset of URLs from Kaggle, GitHub, or whatever, wherever you want to get your dataset, you can get that from there. For best, most of the persons who use Kaggle, GitHub, and repositories, and there are also various ways to get our data. And we use pandas to read this dataset. So I'll explain that too in this section. And from input libraries, and also in Jupyter we use these. We have a lot of files and libraries in Python. So we only use required files and install required libraries to run our project. which is based on cyber attack protection using machine learning. And we know about pre-processing, the data visualization is all right. Pre-processing is nothing but we are actually cleaning the data, and that means removing everything, removing null values, and that's all. So we use a shape, describe, count, dissolve, and the null values duplicate info of the data which we are having, and describe the data. So to describe it, we can get a URL, label, protocol. These three are our labels of our in our data Excel sheet, and then we visualize the data to get a better understanding of the data set. So to visualize that, we use Seaborn, Matplotlib for visualization purposes. And you all know why we use visualization to get a better understanding on the data before and after cleaning the data, that is the pre-processing. We use a visualization process, and then after visualization we split data into train and text data. So why we are using test and train data? Simply we train our model and test our model. To do that, we use train and test. How we divide that? We divide that by our data set, which is URL. We use 80% of that data for test and 20% of data for testing. So we use 80 for training and 20 for testing. So that's how we split the data. And then we split the data set into train and test data, right? So in our case, we use a URL database. So we divide that based on that. After splitting the data 80 by 20, we actually give a label to it, which for input we use a URL and protocol. For that, we use X, and output we take a label. For that, we use Y, and then on the screen we are seeing a describe and SNS dot count plot is all for how the label having the data in our data set. So that's what we are seeing on the screen. And then we use after splitting the data set in 80% in training and 20% in testing. Uh, because we are doing this, we need to train the model with large amount of data and test with small amount of data, so we can get an accurate model for prediction for our cyber attack detection. After that, after these data splitting everything, we load the ML models. Those ML models we use for these. Basically, we are using ML models to predict the threats, right? So we are using, after splitting everything, we use this data to load on ML models, which are decision tree, random forest, SVM, XGBoost, these all. XGBoost, these all, and these all are we write in algorithm based. So let's see how they are going to look. Let me see. Yes, here it is. This is a decision tree, random forest, SVM, XGBoost. Decision tree is used to get a boolean value that is true or false, and it is a tree-like structure. And random forest is a multiple decision trees to get a result with majority, category, and classification. The scheme is a support vector machine, which we use it for trying this for best plane and to get to know the best plane and worst plane of the model. And the XGBoost is a combination of two hypermodels, and it combines two models to get an accurate trained model. So that's why we're using XGBoost. And down we have algorithm for that precision tree, random forest, SVM, XGBoost, right? So we are actually also split the data training accuracy and testing accuracy, and then we print this with training accuracy and testing accuracy, and then we iterate over each algorithm for algorithm train accuracy, test accuracy in chip, and then we print the algorithm name with the actual accuracy value. So this print algorithm dot just 20 and train accuracy 6FTT, and then it prints like down here algorithm train accuracy, test accuracy. In decision tree algorithm, we have 0.92 training accuracy and 0.88 testing accuracy, and similarly random forest, SVM, XGBoost, and so on. And then after that, then we train these models with training data. How we train? Let's see in further our session. So I think you all know about SVM, random forest, how training accuracy and testing accuracy we get it, right? We get this over this algorithm and everything. After that, then next up we save this model dot with dot pkl extension file, which we saw in the last step. Here we first import the pickle and then we name it as model 1.pkl, and then we dump that model's train model into this one, and we load it with the name extension .pkl. So we use pkl pickle files are used in Python to serialize save objects, including ML models. And as I told you before, it is used to store train models and for fast loading and efficient for deploying in real world applications. So that's why we're using pickle. So we are using this Jupyter notebook to save the model and train the model. So that's what we are using. And these templates are used to test the data. And this index we have about contact details, cyber attack detection, and in about we have description about our project, and in contact details we have phone number and email, and cyber attack detection we can detect the URL. So first we go to about, so this is what it is, and we can go to return home and click on the return home button. So and in contact we have this, as I told you before, we have name, phone number, email. If we click enter correct details, then we can get a call and send by email to that particular details where we are entered. And we can also go back to home by clicking on return home. And then let's see next one. We have a detect.html file which we use it to detect our URL whether it is good or bad based on that. And also we paste the URL in here and we set protocol for that based on the requirement URL we use. And then we can detect on that, click on detect to detect the URL, and then we can click on return home, return back home. And to detect, click on that, and we store the result on this one. So detect result, detection result. So the prediction will be displayed like this. This is the syntax. The prediction label for URL and URL with protocol is predicted good or bad. So we can return to home as we click on return home. So no, if we can try again, then click on try again. That's how it's work by using HTML extension files. We have code on the files when I before so I will show you before, right, that folders, right. So we have files in that. Okay guys, let's see why what libraries we required and why we installed those libraries. So here we have matplotlib, cbon, and you know why we use matplot and cbonlib to visualize the data, and the NLTK is a natural language tokenization which we imported from NLTK to tokenize the dataset we have for test tokenization. And we also downloaded and imported the snowball streamer, count vectorizer, scaler, neutralize shuffle, one hot encoder, and these all are for these cyber threat detection. These are all required files and libraries. So we use SQL and feature extraction.txt from count vectorizer and SK model selection to import text, train, and split, test and train splits, and then util for shuffle the data. And we shuffle the data to get the data shuffled and trained on that also. So we can get a greater model. So, and we also imported from metrics accuracy score, precision score, and recall score, and confusion matrix. And SQL and preprocessing, we imported one hot encoder. It is for preprocessing technique use. And from Keras, we install this for deep modeling. So first we read the file based on pandas, and then we perform head, tail, shape, and I already explained what is it. Shape means the data set. We have 3889 rows and 3 columns, which we have a URL, protocol, and label. And we have count for protocol. So we have these many protocols in our dataset, and then we have a lot of URLs: SNMP, SFTP, RDP, FTP, HTTPS, HTTP, so and all of those. And we and perform a is-null dot sum operation to know the we have a zero nulls or not. If we do, we can remove them, and in that case we don't have anything in my case. So that's why I just move on to the next one, and then we describe the data. So we have three labels, and those are a URL. I mean, three parameters: URL, table, protocol, and we visualize the bad good based on the data set we have, and we schedule the data. So because of sibling, we can get accurate prediction and training the model. And then we use SNS to bad and good label and info about the data URLs. And we take 0 as good and 1 as bad. We replace it with true. If there is a true in, if there is a good in Excel, then we replace it to 0, and bad, and it replaces it to 1. After that, we have how many we have labeled. One is 2676, and one is something around like that. And then we have labels good, bad, and we just pie chart visualize that to know the how many we have good and bad, and histogram bar graphs to know the good and bad URLs and everything. And then after that we use a head and tail on good and bad. After that, good and bad. After visualization, we use a streamer, right? Snowball streamer. So this streamer used for text information URL. So it is used to fetch the information from the URL, text information from the URL. So that's why using the streamer. And then we use some head operations and features means we get to know row price matrix of d type, which is int 64. D type means a data type, so this is a d type int, so that's why we get int 64. And then we train the data using training set. We take models to train that, and numpy we take it for mathematical operations, so we import it as np. And we train these models with as we know already, we take decision tree, random forest, and XGBoost, etc. We use these training data to train these models, and based on that, we take a good prediction model. So for that, we use a D tree, random forest, everything, and we also visualize with the line plot on three of them, so to get a better understanding of the data. After everything, we save this model in a .pkl extension. As I told you before, we use this model to deploy faster and efficiency purposes. We use pickle that is used for serialization and serialization and save objects, including even if it is ML models. So that's why using this, and we named it as a model 1.pkl. Then to run everything, we use this kernel, click on kernel, and restart and run all to run all the cells. After that, the model 1.scale file will be saved. Restart and run. Then every cell in this program will be executed, and then the model will be saved on that dot extension file, dot pkl extension file. So for that, we go to the good process to test the model is, first of all, we need to get the path of our project, and then we copy that and paste it on the prompt. Here we use cd to change the directory of to the our file, and then we use python on map.py, which we have stored our files app code. So in this, we use this IP address to browse on browser, and then we get this one. You see, this is what we get when we run that on a browser. So this about contact details, cyber attack detection, and in about we have description about our project, and we can click on return if we want, and then we go to this one. And then contact details is already I tell you about this one, right? If we enter the correct values, then we can get a call and we can get an email. In prediction, we can just let's take a one record, which is a URL to test. So we can paste it in here and then detect. So it will say like this, the friction label for URL is like this, and we can, if we want to test again, we can click on write again, and if we're not, then we can go back to home. And thanks for watching our presentation on cyber threat detection using ML. We hope this project contributes to the ongoing advancements in cyber security. Thank you.